Thank you. I'll first mention that we will actually switch. So we will present together with Irene, and I'll start. So our project was focusing on the cloudification of the one particular type of data in our that we handle, and it is data from cryo-electron microscopes, and also improving the workflows for the data processing pipelines. So the major objectives was to develop a pipeline that would allow us to automatically annotate and archive the raw cryo-EM data with the capacity to then deposit either the data to the public repository or make it available through internal storage resources. Together with that, we also want to export and image processing workflows in a common workflow language using the cryo-EM ontology, and have a chance to deposit that workflows in the workflow hub. So starting with the pipeline for the cryo-EM data deposition. So in the conservative case, we have such a network of the electron microscope is usually in the facility that are run on the internal network, and that is cut from the internet. Of course, in a less conservative strategy, this is directly open to the internet, but that does not influence the way how the implementation I would be describing is set. So what we have and what we use is that we take advantage of that one instrument in that internal network and connect it from a server running remotely that can then operate and allow us to submit the jobs either directly from the microscopes or then remotely from the back. The connection between this internal network and that front end is then secured, and we can and we use either the edu ID for the secured login, or we now also use Google or ORCID identity to log into that service. That service allows us to implement or run initiate the data transfer, and then also send a report to the final user, because primarily the microscope that we operate are operated in the facility. So we do carry out a service for our users. At the back side of that, we run we have in our case in-house computational resources, but this can be also a remote computational resources to which the data are transferred on the fly as the experiment on the instrument is started. And we can run the data analysis and store the data processing tree together with the raw data. This backend computational resource is usually part of the local cloud provider, and the whole solution is based on the federated cloud that, apart from this local cloud provider, will also contains other cloud providers that, for instance, are optimized for the data archival. The whole workflow then also contains the path where we can automatically submit the data from the temporary archive to the public database, if which in case of the electron microscopy data is Empire, or then publish the data on the data archival if that the data set does not fulfill the conditions to be published in the public database after the embargo period. So now over to Irene.
Mm-hmm. Well, that's the solution from the previous one from the data acquisition point of view, but from the point of view from the external user data analysis, what it will be done is that the external user will retrieve the raw data through the Stipion One Data plugin. Maybe at this point the user could get inspired by a Stipion template that could be available at Workflow Hub, and that will have been submitted to Workflow Hub through the Stipion Workflow Hub plugin by another user. The user will continue with the processing, and eventually she could submit through the Stipion Employer plugin the raw data and the intermediate data, and the following pipeline to Empire, providing also the link or DOI of the Workflow Hub entry. And the workflow data we were from Empire will be enriched with thumbnails.
Right. So now for the features of the system, on the data pipeline, the system that we've selected is based on the One Data federated cloud solution. So we use One Data Cloud as a cloud service for the data deposition. For that service, we have developed a Python-based application that we call FS2OD that actually manages the creation of the new data set that is in the terminology of the One Data called one space in the cloud, and adds the metadata to the raw data, submits of course the data into the cloud, and manages the transfer of the data between individual cloud providers. Plus, of course, is responsible for handling the conditions for data archival or alternatively deletion of the data. The data are either accessible directly from the web interface through the One Data interface, so you just need a web browser, or as a part of our front-end system, we are sending the user a link to download the data, or alternatively, or as another option, the data can be directly loaded into the Stipion for the further data analysis. As I already mentioned, the data model, so the metadata are directly available in the One Data, or are also provided stored separately in the YAML format. And we have the workflow for management for the data archival and deletion of the temporary data. In case the raw data is not published or transferred to the public database, then we have a catalog to publish the data after the embargo period. On the front end side, we have developed a service that allows us to gather the information about the data model. So to request the user to properly fill in all the necessary information regarding the data model that we stored together with the data. Again, the application is browser based, so therefore it does not require any additional installation of additional software. The code is available on a GitHub, and as a part of the metadata, we actually store a metadata for 4 different entities. It is information about the service provider, so about the center that actually collected the data for the user, then about the data owner, so the user for who we collect the data. And then we collect the metadata about the sample and the actual raw data. The system allows for automated user notification and provides online job status that allows us to monitor the data processing on the fly and the status of the data transfer in real time. So the whole system is federated, is based on the federated cloud solution, and we're currently using OneData for that. We are having a local cloud provider on site in the facility. So one storage that we have in the facility is working as a local temporary cloud provider. But we have also tested a remote cloud provider that can be used not only for the temporary data storage, but also for the data processing. And then the remote cloud provider for the data archival. The one feature is that we can submit the data to this pipeline directly from the instrument and see the feedback and report on the actual status. Also, the system contains the workflow for the data publication that is contained within the data model. And again, over to Irene.
Mm-hmm. For improving the CryoEM workflow fairness, we have first developed the CryoEM ontology, which is available in the ontology lookup service in BioPortal, and there's also an entry in FileSharing. The workflow have a Stipion plugin for allowing to any user to upload their processing templates that will be recreated with the Stipion JSON and Common Workflow Language workflow that will be enriched with the ontology and the diagram and some basic metadata. Next slide, please. There is also the Empire Stipion plugin that, apart from allowing to the user to submit the raw and intermediate data and the Stipion JSON workflow, will allow to the user to provide the workflow hub link entry, and also we have improved the viewer with some thumbnails and new parameters for allowing to anyone to understand which pipeline has been followed without the need of installing Stipion. And also the OneData Stipion plugin for retrieving data from OneData directly from Stipion. Well, our experience working with another work package guys, well, we have received support from Work Package 1 people when we wanted to submit the CryoEM ontology to the ontology lookup service. We have also interaction with the Work Package 2 guys that were developing the API for submitting work requests to Workflow Hub, and we have we get some storage resources that the Work Package 7 people provide us.
Okay, so what we believe is the impact of our project on the research infrastructure. So first, the primary involved research infrastructure in this case is Instruct, but given the type of the data that we handle, we see the potential impact also on the Eurobioimaging infrastructure, research infrastructure. We believe that with this we can improve the services provided by these research infrastructures by having the data available faster and in a more reliable way. We of course also believe that we can help to improve efficiency by facilitating the data management in alignment with the Instruct data management plan, and primarily also increase the fairness and quality since we are tracing the data during its whole lifetime, particularly for the raw data. what we believe is an impact of the project on EOSC. So what we've generated is a very general pipeline for the data management, which in fact can be implemented to other techniques that are handling large data. In fact, as a next step, the workflow will be implemented in CryoEM facility in Madrid. And we also initiated discussion in the biophysical facility in Brno, that we will implement the strategy there, going towards yet another type of technique and research infrastructure. So the project facilitating the data availability together with the annotation should be yet another impact of the project, so that we provide the outcomes of the raw measurements in uniform way and properly annotated. And of course, throughout working on that project, we've been promoting the EOSC open science standards and best practices within the Instruct community. So for the future work, we still need to finalize one workflow, which is the repository deposition to the public repository, and then we aim to publish this the results of this project, or the strategy that we developed in this project. As a parallel development that is further extending the capacities, we will develop the feedback loop that uses the results from the on-the-fly data processing to manipulate the parameters on the instrument. And we're also thinking about implementing using a different alternative federated cloud solution with the workflows. As for the sustainability, we believe we are well set. So the codes and manuals are available on the GitHub, and maintenance of the solution is guaranteed by the Cyprian development team, and of course also the SciTech EM facility. And with that, I thank you for your attention, and we are open to take questions.
Wonderful. Irene, Jiri, thank you so much for the informative presentation and doing it two-handed, adds a degree of complexity, and you handled that beautifully. So I have a question already in the chat from Phil, who is asking how easy it would be to bring these workflows and implement them at other CryoEM facilities. Is it dependent on your cloud service provider or portable to another one?
Mm-hmm. Actually, we believe that this is very simple, and this will be the first step. We will now run the implementation in Madrid facility during the summer. We expect we will be done within a month. One thing that we need to find out, or one needs to take care of, is that there is at least some small local buffer that can be set as a cloud provider. So that's the only our additional hardware requirement, so to say.
Thank you. Irene, would you like to comment on that question? I see you put a comment in the chat.
Yeah, just let Philip know that currently is adapted to the One Data solution, but I think this could be adapted to another one without a lot of effort.
Thanks. And I had a question as well about your storage. So at one point you said you kind of had a limit of up to 10 terabytes. And I wondered if that's just pragmatic because that's a local size that's convenient. And is that going to be sufficient, say, over the next sort of 2 to 5 years as these data sets grow in size?
Oh yeah, this is only temporary. So when the data is submitted to the cloud, we need to define the space that is required. So we know that, or this is safely above the threshold of the standard and above a standard data set. And once the data acquisition is complete, the size of the space then shrinks to the actual size.
Wonderful, thank you very much. Okay, so we have